recording here. Project management stuff. Well, yeah, every fair enough. I mean, that's true. Project management stuff determines whether the technical side of a project can actually deliver any value at all, whether it becomes a hellscape of a project, or whether it is a project that is viewed as a gateway to many future successful projects and a really enjoyable experience. So that is true. This whole class is chock-a-block full of project management stuff. There will be times where we dive into specific technical nitty-gritty matters as required by student understanding, whether it's transaction management, issues having to do with the Liskov substitution principle, matters having to do with containerization, design of build pipelines, components involving multi-tier architectures and scalability and stateless management for effective handling of many connections, particularly in a bursty way. There will be times where we talk about technical topics, but they will be within the scope of delivering successful projects, and in part because they interact with project success as mediated by management concerns. A lot of our discussion in this class will be on the process side as well, within which those technical matters are addressed, and which lead to ability to manage effectively the challenges associated with projects at scale. So, that's a good reminder, person who put that forward, of the purpose of the course. Risk management is one of those areas that is central to the course. In a way, you could view all of the course at a certain level as being about effective prevention and management of risks. It's a thread that runs throughout the course, and we talked in the videos appropriately about particular means for risk management, a topic to which we'll come back here in just a minute. Positions with accountability is exactly right. When we say accountability, what are we talking about? When we say it's a position that comes with accountabilities, or that someone in that position of build master or of dev lead has accountability for a certain area. What does that imply? What does it mean? Yeah, they have to take responsibility for it. So Tanner, that's excellent. Take ownership of. They're the one who makes sure these things get done, and they're the one, and Tanner put exactly the right word, responsible for watching it to ensure it gets done. They have a sort of, they're the point person, the person who's sort of the single person who can speak with authority about that subject, not because they're not doing the work themselves as part of the particular substantive work to be undertaken, but because they have ownership over it, and that comes with responsibility, and it comes with some privileges. So that's good. peer reviews. Yeah, there were components of peer review in there, and peer review can take many forms. Can anyone mention 2 types of peer review? I could have asked about 6 types, but because there's a wide variety. But could you just throw out there too? So code review, yeah. That's a kind of blunt term. But it sort of is fairly non-specific. But it is a subset of all peer reviews. There's a lot of peer review, particularly early on, that you should be doing over the next few weeks that reviews things other than code. Some of the most impactful types of peer review don't take place on code. They take place on requirements documents, on architectural plans or design plans, on test plans, risk management plans. These things can't be tested. You can't run tests on a requirements document in an executional sense. But they can be peer reviewed, and they need to be peer reviewed. They must be peer reviewed for your projects. So that's good in the sense that it's a subset of all reviews. So I'll take that advisedly. But there's many specific types of peer review that others have put forward. For example, Hong here on peer desk checks, where it's really an informal look over of code or unit tests, often spontaneous, sometimes at the spur of the moment, sometimes requested in the course of a day or what have you. But it's not terribly formal. It doesn't require preparation and a separate meeting where things are distributed, or preparation well ahead of time. It doesn't have a follow-on meeting typically, which involves, dealing with making sure the punch list of items have been dealt with. Formal inspections is another type for which each of you will be responsible. That put forward by Madison. Excellent. That's exactly right. So formal inspections are more structured. They involve multiple roles. They involve pre-review. They involve follow-up commonly. The person who presents the artifact, whether it's a risk management plan or an architectural plan or a requirements document or some code, is not typically the author, and there are people in different roles as readers of the code, people who keep track of time or make sure the process is going accordingly, going quickly, within the time frames. And there's prep well ahead of time. People come into the meeting having reviewed the artifact accordingly, and they leave it with a set of issues to be dealt with. Not so much the solution to those issues, but the issues to be resolved, to be followed up, to be looked into. So excellent. Madison and Hong, my hat is off to you, and Tanner for putting peer review and pair programming is another type. Yes, it's a perfectly good type of peer review. It's not just a perfectly good, it's an outstanding one. At the naive level, it looks like duplication of effort, right? You have 2 people working on one piece of code rather than working on a separate piece of code. But it's actually a fantastic opportunity for many reasons. For spreading knowledge, for, yes, finding issues and preventing them, but also developing a deeper understanding of what's being reviewed, facilitating the finishing of that work, making sure now there's 2 people who know about how that works and can speak to it, maybe in another review, maybe in putting together unit tests for it, etc. Pair programming is shockingly effective, even when it's a very senior person and a very junior person paired up. The senior person learns, often something by the presence of the junior person. There's new insights, new understanding gain, so on. So that's really excellent, Paul. Good. So we have these types of peer review. I kind of dove down, but there were further topics covered, sort of popping up again to some of the discussion. So regular updates. I think what that's referring to is incremental delivery, possibly referring to continuous integration, but elements of continuous integration, but incremental delivery. The reason I say continuous integration is something that's emphasized in that syllabus. And I'd again remind you, if you haven't done it yet, be sure you do it in the next couple of days. Remember this bulleted list, which talks about, requirements for your project by which you will be judged by me. And the TA, you'll be held accountable, these are stipulated requirements for your project, not for its own sake, but so that your project will succeed rather than encountering all sorts of grief. Okay, so be sure to turn to that, and I would just note here that within that, there's a discussion of the need for regular updates with respect to continuous integration. So when someone said, when Udav said regular updates, it's conceivable he's talked about the stipulated requirement of making sure that the members of the team refresh against the code base frequently, rather than waiting till late in the game to do that, till just before they check their code. That leads to big bangs. That leads to problems where suddenly their code won't compile. The tests they've written won't run because of changes elsewhere in the code base. And they're not able to deliver it in time because of the volume of other changes that they have to integrate in, maybe merge conflicts with their code. Assertions was another one Madison put forward. My hat is off to Hong and Madison are on the leaderboard right now. That's right. So assertions. Can someone remind me what's the job of assertion? Why do we use assertions? What role do assertions play within our code? Why do they help at all? Why are there whole best practices associated with them? No one to stop. Okay, I'll say that there's some truth to that. Tells the program when to come to a screeching halt. Tells the system when to go no further. Runtime checks that verify developer assumptions. Beautiful, huh? Yeah, they assure assumptions on which the developer is counting, on which the code about to be executed is relying. Now, I'm going to refine something Hong said, but data structure integrity, algorithms, algorithmic behavior, the invariance that it maintains, the fact that when it's done, the post conditions are met, that that this data structure has no null keys in it, or that it's on empty, or that the array being returned is in assorted order, or the value being returned as non-null or not zero. So that's good. Now, Hong used a word here, input validity, which at a certain level could be true. I'd probably give partial marks for it in a pop quiz or well, in an exam. I'm not responsible personally for marking the pop quizzes, but I am every question, every person on the exam. And I'd probably give partial marks. And the reason is, yes, to a point, that like data structure, integrity, and algorithmic behavior, what you're passed as, if you talk about inputs to a method as being like the arguments passed to it, passed as with the formal parameters. The information it needs to do its job being passed to the method. You want to check that those meet preconditions generally. You want to ensure that you've been given the information you need to do your job. Now, there's a bit of philosophical difference within the community on whether you should simply bomb out, you should stop the whole system if those are not met. There's some thought that, so a group will argue that's definitely true. You want to signal my assumptions, my explicit assumptions, as communicated with precondition, have been violated. You're using me improperly, and I'm going to stop this. Just like a company that finds that a client or a supplier has been violating the terms of a contract, might stop that contract. Say, hey, you breached the contract's off, right? There's an argument to be made that needs to be signaled to the world, that, to the developers, hey, this code is being used improperly, go fix it. So in that sense, yes, there's another group within the development community that says, well, wait a minute. That's all good. That's all well and good for developer code bases. But if this is shipping code, do we want the system to stop in its tracks, grind to a halt? And you can argue about this, right? There's reasonable arguments to be made either way. A lot of the time assertions are stripped out before it ships, before it goes live, before it's in production, for this reason that we don't want the user to have to face an assertion failure. On the other hand, sometimes assertion failures may still be like stopping the program in its tracks, maybe the least bad of the options when it comes to a real world error in production code. Why do I say that? Why? Okay, I really like some of what's being put forward by Madison and Brandon here. Why is it that in production code, why do I say like having the system come to a screeching halt, like die, like you can't continue. Sorry, out of luck. Why could that be the less bad of certain options? Let's suppose that this assertion doesn't occur, that the programmer's assumptions have been violated, but we've stripped out the assumption, we've removed it, we haven't put it there. Why is it that you might say that's the least bad of the options? Industrial setting, but better for a machine to stop that could have an error that could cause bodily harm to operator. Darn right. So that's a really good point from Connor. Sometimes continuing on could lead to cascading errors. I mean, like knock-on effects. Like it leads to errors which could cause real harm, cause a plane to crash. It could cause an imaging machine used in medicine to give the wrong diagnosis, or give a wrong impression of a patient's health, which could cause them to be misdiagnosed or not diagnosed, right? It could cause an autonomous vehicle to crash or kill someone, right? It could talk about bodily harm. And, and you might think that those are overblown, that, the large majority of the industry isn't working on mission critical systems like that. But the truth is, it could cause a grievous amount of damage. Even without that, it could cause companies to lose a lot of money. Look, imagine the code continues on. Who knows what it will do, right? The assumptions have been violated. So who knows what will happen? It may stick bad information into the database. It could write out a corrupted file on disk that cannot be read. It could destroy the integrity, like the ability for a document to be read subsequently by the user. It could deliver, in short, negative value. Right? It could corrupt the data structures in ways that prevent them from doing the things they have been doing till then, opening this document. So, like, continuing on rather than bombing out might sound like what you want to do. Bombing out is definitely not going to deliver value. Who knows? Maybe if it continues, it will deliver value, but it might deliver negative value, and without them knowing about it, right? Without them having the option of stopping. The argument, though, is made that, wait, the mature thing to do here isn't to bomb out. The mature thing to do is to notify the user, is to close up things and avoid that integrity, but to help it fail more gracefully, help it fail in a way that won't just lead to, savable information from being saved safely. That it's, being more mature in how you leave, rather than just saying, like, sorry, you're out of luck. Here's a stack trace. Go show it to your IT people. Which is, admittedly somewhat off-putting, right? That it may be better. There may be better things you can do that are provably safe. So there's an argument back and forth there, and there's some really interesting technical issues when it comes to that. And behavior will be undefined. The question is whether you are really careful to put in place mature code that won't continue. That's out of the question. We can't continue. The assumption's been violated. But could you do something different to fail more gracefully, like to close up shop, close up files that have been open in a way that doesn't write anything more to them, close up, close database connections, ensures that, caches are appropriately flushed, that are known to be safe or what have you. Could you do something like check additional types of data structures for looking for other problems that might be there, that might spot other problems that developers should know about, et cetera? So, are there additional things you could do? Could you use a brute force algorithm rather than using this algorithm which gave flawed results and is meant to be a lot more clever, a lot more, use really close logical reasoning to try to increase efficiency? So there's some mature discussions to take place there, but it's really obvious from people's comments here that you folks have been doing your homework. I give a shout out to Madison, help find errors closer to where they happen. That is the job of assertions. And it's amazing how much that can help debugging. Well, an error occurred, and it occurred, by this certain point in the execution. And if your code has lots of assumptions, lots of assertions, you may find that long before, you would otherwise. It may save you a massive amount of debugging time and give you real clues to, try to box in where the error is. And your code should be littered with assertions, lots of them, preconditions, postconditions, invariants, history properties, basic things that you're reflecting, you're thinking about, you're counting on your code. I like to advise students. I like to advise professionals. Done consulting for software companies and like to advise them. When you're reasoning about your code, when you're thinking about, what's true here. So what do I need to do? You're often reflecting, what do I know? You're sometimes very explicitly reflecting, what am I counting on? This array passed in is already sorted. This dictionary has no duplicate keys, right? All the values in this array are non-negative. These two integers passed in, one is, n, and the other, I, is between 0 and n, not including n. Like, when you reflect on your code, to write the code, you're often reflecting on, like, what do I know? What are the raw materials I have to have this code do its job, right? Use that as a chance to write down assertions reflexively. And they serve to document the code. A good assertion can be every bit as good, but even more useful than a good comment, because it actually checks operationally. The condition, it specifies it crisply. And that's really valuable. There are times where we use assertions, even at a higher level. In a testing code base, we may use assertions, for example, larger code base. Well, in development, we may use assertions to check the correctness of our algorithm. I mentioned this idea of often it's not always, but there's a fair number of cases where writing a brute force algorithm is pretty straightforward. It's not efficient. You don't want to use it in production, but it's very straightforward, and it's easier to immediately have confidence in the correctness of it. Writing a really clever algorithm, well, you folks know from 360 probably, it requires a lot of thinking. It requires a lot of reasoning. And sometimes it requires some finesse in coding it, right? You got to get the conditions just right, and there's a bunch of them. You're dealing with sophisticated trees, whether it's red-black trees or splay trees, these complex data structures, B trees. Sometimes it's fairly straightforward to write a brute force algorithm, but it's prohibitive for production code, and it's harder but vastly faster to write, good, really performant, sophisticated algorithm. Well, in assertions, you could actually compare for smaller problems. Does the brute force algorithm give the same answer when called as the efficient one? And you may say, well, why in the world would you want to do that? You have to call both. Well, yeah, because you're making sure the efficient one is correct, so you can stop using the brute force one in production code. So assertions can be used at a higher level too. It's not merely is I less than, between 0 and less than n. It's not merely is this index within the bounds of this array or whatever. You can use it for a higher level correctness as well. But I want to go back to Hong's point. Checking input values, because there's one thing you don't want assertions to do in input. Assertions should not be checking user input and just bombing out if it's not good. If you ask someone in a web form, enter your age, and you're expecting something between 0 and 99, age in years, right? Mind you, it would be a pretty precocious 0-year-old to enter their age, right? Maybe you're expecting between 1 and 99. Okay, 18 and 99, right? if someone enters 17, they shouldn't be using the system. Or they enter 100. Well, we can't just bomb out, right? We can't just say like that violates my assumptions. Like, get out of here. Like, sorry, you're out of luck. You can't do that. That's not responsible. It's to encode programmer assumptions involving things programmers have control over. And it's to get them to fix those things. Similarly, and this is important, you can't like bomb out if you're out of memory. It's like out of memory, all everything is off the table now. I'm out of here. Go get more memory. That's not responsible behavior. It's not responsible behavior to bomb out when the user enters something they're not supposed to enter. You have to be more mature than that. When you're out of memory, you may not be able to continue your operation, but you want to give an appropriate message that's diagnostic, and you want to clean up. You want to close those database connections. You want to close those files. Maybe flush things out to disk, whatever. Write out the files. You may not be able to continue, but you want to be responsible, and mature. So yes, if it's checking inputs as in preconditions for a function that come from elsewhere in the code base, yeah, you can do asserts related to those, because they're things other programmers in the code bases have control over how this is called. But we can't do that with like user input, in fields. So that's an important distinction for assertions. And I just want to put that out there as a pip. Yeah, I'm going back to this wealth of things people have put forward. So Brandon says habit of checking pre and post conditions. That's exactly right. We'll probably talk in the class about those other things I mentioned, invariants and history properties. You should know about some of them from 360. There's certain guarantees you're expecting, certain properties you expect to hold of a data structure for certain algorithms. But more than that, there's certain properties that you are aware of that should be guaranteed. Maybe that this data structure is read-only, that it's not going to be changed, and therefore you can count on its contents now being the same as its contents a bit later, right? That's a history property. It's not changing. Or that this value never decreases, that this counter in a loop is always staying the same value or going up. Or conversely, another one might be going down, right? That's a history property. And invariance might be, I've mentioned above, right? This data structure has the same number of entries as this other one, right? These two arrays passed to me are of the same length. All the values in this that we are dealing with are non-negative. This dictionary has non-null keys. No, there are no null keys, right? Or all the keys in the dictionary are unique. So these are things we'll be counting on commonly, and some of them get expressed in preconditions, but there are times where it's more of an invariant on like a whole class or a history property demonstrated in an algorithm. So keep that in mind. There's lots of opportunities for assertions. When you put assertions in your code, I will be happy. When you don't put your assertions in your code, I'll be unhappy. And you want me to be happy when I'm marking your code. So please put assertions in your code early and often. As often as you can. Okay. Lots of good reasons. It's self-documenting. Prevents collateral damage. Yeah, a good point. This whole area of you can have unintended effects of continuing if programmers' assumptions have been violated. It's undefined what will happen. Right? And people should be clear about that, right? When you have a piece of code and there's preconditions, if the preconditions are violated, it's not guaranteed. The post conditions will not be guaranteed to hold. They're contingent upon the preconditions. So if the preconditions are off, you can't count on the post conditions holding. You can't count on its behavior, and it's unsafe at any speed to continue. Yeah. Yeah, so Ronin had said assertions are better than the program completely crashing. Yeah, assertions can be handled more gracefully, as I said earlier. And what I'm not looking for any, like, there's a lot of obligations in you in this class, and I'm aware of that. I'm aware it takes time. I'm aware it takes effort. It's a lot better at time and effort, and a lot better for the students than dealing with problems, conflicts within the team and a project that's failing and failing bad, and quality problems have blown up, and the code base is almost unmaintainable, and the stakeholder is unhappy. Like, you'd rather be thinking about, like, okay, how can we do retrospectives better, or how can we better communicate about the what tests relate to what requirements and test matrices or what have you. Better think about those things, like stay up worrying about how badly the projects go. Okay, I'm just looking through here. I'm really pleased by a lot of these comments. So I think we've kind of mined that area of some of our discussions, or some of these topics we've been speaking about. Why do we build things incrementally? Why do we deliver projects incrementally? Many of you will recognize this as a key part of the agile movement that took the world by storm in the 90s. And why do we do it? Fast feedback. Yeah. User feedback. So excellent. Brandon, Jason, Aladdin, excellent. Fast feedback from whom? From whom do we get fast feedback? Yeah, excellent. Robert has another key point here. And Maria as well. That's excellent. So fast feedback from users. Yeah, from users or customers or clients, stakeholders. Those could be users. Those could be end users. Sometimes they're people that are speaking for users, right? They're the representatives who are procuring the system, asking your company to develop this system, like Zoo to develop a system, or ESTI to develop a system for them, for their users. But they could be end users. They often are end users themselves that want to get their hands on the system and use it. So that's good. You get feedback from stakeholders and sometimes users. That's one virtue. And that can cause you to change your prioritization, can't it? It can get you to decide differently what you're going to do for the next deliverable. Here's take it from an old man, folks. Take it from an old man. Look, we computer scientists, we spend like so much of our lives thinking, interacting with software systems. We've seen all sorts of different types of systems, from the very clunky to the slick, right? So much of our lives is immersed in technologies. And so when we go to conceptualize a system, new system that we want to build. We often can envision it fairly well, but there's whole classes of users out there who don't spend their lives immersed in this stuff. Yeah, okay, they use their smartphones in the course of a day, and they sometimes get on their laptops and they use PowerPoint or whatever, but Outlook. But their computational world, their experience of user interfaces is far more constrained. Now, admittedly, not only often do they not see the very best, they don't see the bad and the ugly too, which we get to see. But they don't have the breadth of experience. Their focus in life is on different things. They're focused on running a dental practice, or delivering for patients, or running pension plans, or dealing with delivery of goods, making sure that goods are distributed in time, for an equipment manufacturer or whatever, right? Their focus is others. And it's really hard. It's perhaps for us surprisingly hard for them to envision a system. So they may give you some requirements and discussion, but often they're not going to give you the most obvious ones to them because they don't even think to mention them. Well, of course, like dental practices, need to keep track of this information for billing. Like, we don't know what, but it's so basic to the practice they don't even mention it, right? But also, they may not think to mention something because it's a technology thing that they don't know. They don't think to mention that, the system they want to build has to live within the memory requirement of modern smartphones, because they don't know how smartphone software works. They don't know, what has to remain in memory, what's not. They have no idea, how big this program. So derive requirements, they're not going to know. They're also not going to know issues with, or often they have a hard time conceptualizing the user interface. They're not thinking about all the different ways it could be done. Oh, you've seen that, you've seen this, you've seen that. It's really slicker to do that. That interests a lot of us. Doesn't interest them typically. And so they don't, when they ask you to build something, they often have a very inchoate, a very rough sense of what might be wanted, sought. And when you get it in front of them, like even an early prototype, it makes their ideas much more concrete, and they can often provide much better guidance about what they want and what they don't want, right? You get much more concrete, specific understanding on their part, and they can really take it forward. And so it's not often that they just, capriciously change requirements. I was thinking that, now it's this. No. It's often they have much better understanding of what they need. And the truth is, for to be honest, we do too. We learn to think through it a lot better when we see it. We recognize what we don't want, or do want. Oh yeah, we have to deal with that issue. And so it helps you get feedback from those users, darn right. But that feedback often is in the UI, or it's new requirements which come to the fore, derived requirements. Things aren't directly implied, but they're not the things they want directly, but they're things required for the things they want. Like it has to fit in the memory of a smartphone, right? It has to be encrypted because it's like patient-related information that be disastrous for it to leak. Their phone has to work offline. The software has to work offline, even when they're not connected to the network. What happened? So ensuring what you're creating is accurate to what your users want. Yeah, that's right. Reduce complexity. Yeah, so and reduce risks. Good. Why is it that shooting for a smaller period of time, say a 2-week sprint, or we work on something for 2 weeks and deliver something they can look at. Like, why does that reduce complexity? I would argue it does along a couple of ways. Well, maybe I'll address Aladdin's question. How do we effectively mediate this disconnect they have with the technology? Well, you have to help them understand the derived requirements. That's your job. They're not technologists. They don't know that, it's hard for software to work offline and, about what's needed to deal with going back and forth between online and offline, and that there are multiple devices a given user has, and some remain online and some go offline. When those other ones come back from being offline, they have to sync up with the others. Like, that's not their world. That's your job. That's what makes us hard, being a technologist. Like, that's one of the things that complicates our lives. But it's not that we're just defenseless. We're just vulnerable. We can't do anything about it, and we just get hit gobsmacked by it. No. We can be savvy to it. We can know, look, we have to help educate them. And this is why it's a dance between the two parties. Education on both sides. They're experts in your domain. You're experts in technology and software development. And you end up having this conversation about what they're requiring to realize their vision, what it implies technically, and what are the ripple through effects, that, okay, you're going to have to do this work, to put that in place. And there's not a good way on a smartphone to do, run large scale deep learning models to train them or something, or that can't fit within the time frame of the turnaround that they want. I mean, like, there has to be this sharing of understanding to deliver value. And it's true that they have to be mature enough to recognize that goes on, but generally they are. They're aware, they've no clue about a lot of things, and they don't know what it takes to develop it. So they're looking to you to help educate them about that and tell them, well, this requirement they want, it sounds simple to them, but it's going to require, a lot of time and a lot of expertise and a lot of challenges and impose some risks because of X, Y, or Z. Or it's going to require people have, this version of iOS and Android and not before. We're going to require integration into the and the Saskatchewan Health Authority's, authentication database or whatever. It's going to require either one device per user or a heck of a lot of extra development to do resyncing between multiple devices. These are things they're not, by their background, equipped to deal with, and you need to know that, and you need to fly ahead of that plane. You need to integrate with that. Okay, complexity is reduced because changes. Excellent. Complexity is reduced because changes are easier to make when less is done. That's exactly right. When less is contemplated, you break it up into smaller, understandable chunks. Now here's the deal. This is a really important point. This is one of the big advantages of incremental development. You avoid the big bang. You avoid another form of big bang. You avoid the problem where, all these changes of tons of different types of changes are folded in and they all interact. And if there's a bug, who knows where it lies? There's less that change, the delta, right? The change that occurred is a lot more localized. You only modify this, and this. So if you encounter a defect, if you encounter a new error, there's not too many places that can live. It had to have come from one of these 5 changes. And it's a lot easier to test. It's a lot easier, well, particularly to debug. And you can often track it down a lot more easily. If you've changed hundreds of things across the system and it's getting this error message, that's a pretty big task to figure out where that came from, right? It's easier to roll back, someone said. a little bit earlier. I think that was easier rollbacks. That was Robert. That's exactly right. You can roll back, and you can try disabling some of those changes if needed to track down, to wolf fence the deal, to figure out where localize the error. We changed these 3 features. Suppose we only were to focus on those feature changes. We'll have a code base with that, not the other 2. How does that, does this error still come up there, et cetera? There are pairwise errors, and we'll talk about those later in class. There's a set of techniques that help us deal with those, but a lot of this issue of kind of tracking things down is errors coming from particular areas of the code base, and there's less confusion. The testing can be more focused as well, right, on those areas. I mentioned it earlier. If you don't speak to the client for months, build a feature which becomes structural to the code base, and then they decide that's incorrect or not what they are matching, it's much longer to undo. Yeah, this is a big problem with users. I've seen companies essentially go under because of this, because they're so late and they don't speak to the client for months. When it comes time around, either very commonly clients notion, they forget what they promised or what they committed to in terms of what they wanted. They forget what they say. Sometimes their needs genuinely change. Since that point, there's been this new tax law put into place. Those tariffs, wacko tariffs came up from the US, or, they've merged with another company, or they're going to merge with another company. And so sometimes their needs genuinely change, but often their perception of their needs, or their understanding of their needs, or their thinking about their needs changes. And often it piles on. If you haven't talked with them months, they think, wow, I've been waiting a long time for that. Might as well get them to develop this other feature as well. Waiting so long, get them to, if I'm going to wait this long, I want this other feature too. And then it piles on. It's quite bad. That's right. So let's see. So managing expectations, yes, is a lot of needs is about managing expectations. It's about, look, the same work, same people on the team, same requirements, same delivery, can be viewed as a great success or as a failure, depending on the promises made earlier. If you say, we'll deliver this to you in 2 weeks, and you deliver it instead in 2 months, it may be viewed as really disappointing and it's limping along as a project, and a mark of it can build distrust with the development team. By contrast, if you promise to do it in 3 months and you deliver in 2, they may be thrilled with what they get, and they have great confidence in the team. And you think, well, wait a minute, isn't it better the client expects it in less time, though? Well, yeah, but you have to deliver on it, right? And so under promise, over deliver often helps success. Yeah, but incremental delivery can help set expectations and manage expectations. Here's the thing. It's an odd thing psychologically, but it's true. If you get people to estimate how long something would take, and you give time frames of like months to deliver this whole package of work, larger deliverable, and there's the question, is 2 months, 6 months, whatever. It's very hard for people to give good estimates. We'll probably talk about some ways you can get closer, but it's hard. And the thing is that people don't think concretely about their next 6 months or next 2 months. it's often very abstract in their mind what they're going to be doing. Now, again, the techniques to make it more manageable at those longer scales are to break it down into very small components, et cetera. To estimation by decomposition. Sometimes you decompose, you take it apart into these pieces in your mind. But it's very hard for someone to just kind of spitball and just give an estimate how long it's going to take. It's totally unrealistic. Often the estimates they give out, they're disconnected from reality. Really smart people giving very bad estimates. When I was at MIT, the joking rule is when you get an estimate for a software project, you multiply it by 3, add 1, and shift up to the next higher units. So if you estimate it's going to take 2 days, multiply by 3, 6, add 1, 6 days, add 1, 7 days, and you shift up to the next higher units, 7 months. And that, of course, is a joke, but the point is very smart people can give very bad estimates at those large scales. If you're talking about delivery in a week's time or 2 weeks, you start to think in very concrete terms. Look, I'm away for that friend's wedding Thursday and Friday of next week. This other person is out sick right now. We only have these people at hand to do the testing right now. What would this feature take? And, Sue, who is required to deliver on that feature, is really busy with this other specific work right now and is maxed out. Probably have to get in her queue, which won't happen until next week. And then we can't begin the testing, until of the final feature set until late next week. There's no way we can deliver that in 2 weeks. You think in very concrete terms, and that's what's needed for good estimates. Thinking in very specific terms on the supply side of people, the demand side, what's needed, and who's there to deliver on it. Shorter time frames gives that to you. Yeah, they avoid scope creep. That's right. You time box it. You're really limited by those concrete senses of what you can do in that amount of time. And chances are, when you get back to them, their needs may be a little bit different. And you don't put your time, pour it into things which are not responsive to the stakeholders' needs. So these are some good things about incremental delivery. Also, we learn from our incremental delivery. We learn about what's hard. We can address high-risk things in these in early cycles, such that those aren't just bundled up into overall estimates, which have to reflect huge uncertainties. We deal with them early. Incompatibility between technologies, and problems with this platform, the smartphone platform, and this technology, or what have you. So it lets us get high-risk things done early, and that's what I'll be generally seeking for you to do. You can fold in this spike prototypes early in your project, and you'll do well. So there was a question from a student that came in through private message here. When working on a project, can we move teams? Being dynamic, move dev team to test team, or test team to dev team? Well, I want to highlight here that this is something well addressed in the required document that I've asked all students to review, and for which they're responsible in their actions during the semester, and even for pop quizzes. So I just want to make sure people are on board with knowing about this. I mean, it's in pretty plain English. It's not just possible, it is required upon each successive deliverable iteration. the leads may or may not swap. That can be decided by the team. But the development team in incremental deliverable I must become the test team in incremental delivery I+1, and vice versa. There is mandated swapping. Now, you may wonder why this is. Well, it's a lot of good reasons. What we found before we required this was that teams become very unaware of their situations of the other. The test team becomes disconnected because of lack of development communication from developers. They become disconnected from the reality of the code base. They don't understand how it works, etc. They don't understand how some of the technologies work. The dev team doesn't understand the testing technologies and the testing needs and the cycles needed for them. And all too often, what happens is the dev team in this class, or in those earlier projects, would throw over the, so to speak, the code to the test team, unrealistically, like ludicrously late, like one day or like 6 hours before it's due or something, the deliverable. It's like, okay, go test it. I want to highlight that too is completely unacceptable. And there's this general issue that the dev team views the test team as kind of a lesser partner or something. And never is there a more mistaken thing, I think, that has done deleterious service to disservice to projects. I want to highlight that related to this is the fact that we've also instituted feature freezes, which are sometimes known as code freezes, but we have to be careful when we say code freeze. It does not mean freezing fixes that are in place in the code base. It doesn't require freezing refactoring in the code base. It requires freezing introduction of new features. And I want to highlight, this is really important, the test team or the dev team needs to provide code to the quality assurance team, including our recommended buddy testers. We recommend that developers have a pair who's a tester for this iteration, and then they swap and they can pair up in the reverse capacity. The developer becomes the tester becomes the developer. Throughout, and the code should be delivered throughout the development of the incremental delivery, delivered to the test team. And it needs to undergo a feature freeze at least 3 days prior to deliverable. After that, no new features should be put into place. But it does allow addition of tests, fix of defects, additions of assertions and specifications, refactoring, as long as it doesn't change. So refactor means changing the code like to improve quality without changing functionality. Now note this. For each feature commit to the master branch, so committing of a new feature after a code freeze is subject to a 5% penalty off the deliverable mark, each one. So it is not acceptable. It is not acceptable that the dev team, toss the deliverable over to the test team in the hours or day or two before the deliverable. No. Features have to be delivered 3 days before. I'm looking at your code base. I'm checking on the commits. I'm doing git blame. And I'm looking at, the commit record. And looking at the PRs. And I will be policing this. And you'll be docked off if you get that, if you are tossing over features prior to deliverable. And you may protest, well, that means we won't have those features in deliverable. Darn right, it means that. Yeah. I want the priority in this project is quality, well-tested, well-documented, quality assured, peer-reviewed. That includes peer reviews of pull requests, code bases, and of systems. And it's unacceptable, not acceptable that they be tossed over. And often that leads to salutary, healthy investments in other things, like getting started on that development early. Maybe it's not yet ready to be taken out of the oven. Maybe it needs to wait to the other cycle. Quality over early release of features. Please remember that. So please remember there's feature freezes in place. That is instituted. But you shouldn't need me to read these things to you. You're responsible for this list. And I'm contemplating having a quiz, which will test you on appreciation, on understanding of this list. I'm not going to test you on your appreciation in the sense of like whether you'd like it. I'm going to test do you know it. Okay. So would I be able to go over in more detail responsibilities of a project manager? Absolutely. The project manager is the foremost accountable position here. They're the point person for the stakeholder. They are responsible for coordination across the team. That means coordination of the dev team, the test team, making sure the risk manager is on their job, making sure the build master has what they need. There's sometimes there's two. So I'm gonna say what the project management isn't first. Okay. I'm going to emphasize two things the project manager is not, which come up a lot. One is that they're like the Uber developer. They're like the Uber technical person. And they are the best of the technical team. And they're the one who rules the shop and, does the best coding, best quality, and have understanding the best technical. That's complete BS. Like, no, that's not the job for the project manager. You want to contribute on the coding side? You think you want to do that? Be a developer and a tester. Be a developer. You might even be developer lead. Do some architectural planning. Do some design. Maybe you're really good technically. There's some great folks technically. Great. The dev team is for you and the test team too. Or you could be dev lead and maybe stay in that position if that's agreeable with your team. Don't be on the project manager side. The project manager will not have time to contribute to the code base, typically. Do I absolutely rule it out? No, but it's a bad team. It's a bad sign if the PM is contributing to the code base. There's a lot more important issues for them to be attending to. Putting out fires, facilitating things, coordinating meetings, making sure work's getting done, planning out the order of the development, and talking with the stakeholder and communicating with the stakeholder, talking with the leads, making sure they work together well, dealing with incipient conflicts in the teams and negotiating that. Helping to mediate that. They may assign many milestones, but it's typically the dev lead. Well, okay, let me get to the other thing it's not. The other thing it's not is some Napoleonic leader says, like Washington crossing the Delaware says, like, there, we will go there. No, it's not that like grandiose. So I'm a serial entrepreneur. first company I helped found and ran. We hired a former VP from IBM. He was our president. Great president. Very senior guy, extremely knowledgeable, working in the technology space as manager for decades, or a decade or two by that point, I think, probably two. Great guy. Went on to become head of MIT's entrepreneurship forum. Anyway, his job was to he said, look, my job is to facilitate, coordinate, remove barriers, help the people who are in the team do their job to their greatest potential. That's what his primary job is. How can I help you folks work better? How can we help make sure this comes together in time? But it's taking accountability too. He'd be dealing all the time with the clients, communicating with clients, making sure he knows their concerns, or making sure that we can be situated to address those concerns. If there was a conflict, a disagreement, he would seek to sort of talk with the parties. They're involved in triage, like deciding whether or not a feature should go forward. Okay, this is a feature, it's a bit buggy. It has some low priority errors associated with aesthetics things, but there's one occasional thing that happens. We're pretty worried about it, but it's a key point of deliverable value. Should we go forward with this, or should we exclude it from the deliverable? They talk with the dev lead and test lead to make sure this, and those are key, coordination things that they need. They are someone who's commonly involved in making sure the project delivers on time. The project deliverable comes together in time. They may delegate some of that to someone who's like the deliverable responsible person, but the project manager is going to look over them and be talking to them. Hey, is this coming together? What do you need to do your job better? Do you need help with that, etc.? They're taking ownership of making sure that gets handed in time. They drive the peer reviews, the inspections, make sure the inspections are getting done, make sure the team is adhering to all those bulleted lists of things that people are aware. They help spread knowledge of changes and requirements around the team, so you don't get half the team thinking the old requirements apply, new team thinking other ones, and they work, they pass like ships in the night. They work across purposes with each other. That's right. So Maria asked questions also about the dev and test lead switching. As stipulated in that document, dev and test leads may or may not switch with each other. Let's be clear. And I'm saying this because the wording is ambiguous out of my mouth there, but it's clear in the document. The dev lead, when they switch teams, so first of all, dev and test lead may stay in their positions or may switch with their teams. People elsewhere in the team are required to switch. They may switch. But beyond that, when they switch, if they switch, like the dev lead doesn't necessarily become the test lead. The dev lead could turn into it could be a tester, contribute as a tester, and someone else could be the test lead for that group when they transition to the test role. Similarly, the test team, the test lead does not have to become the dev lead. They could become a developer and someone else could step into the dev lead position. So in other words, the person who is the dev lead, even if they switch, doesn't necessarily become the person who's the test lead and vice versa. Hope that's helpful. Part-time risk manager done by what are the other roles, and do we take turns with it among the team? I would suggest, I'm not opposed to that, taking turns. I would suggest the risk manager. So the risk manager is a part-time position. It should not be done by the project manager. They're too busy. They are busy with these things that lead to project success that I've talked about. It should not be the build master. They are busy as heck. You might not think that they're going to be busy because the project's evolved. It should not be the dev lead, and it generally shouldn't be the test lead either. It should be someone else, but it's not a full-time position. So it could be one of the devs, it could be one of the testers. Is commonly the case. But it's an extra level of responsibility for that person. I'm not opposed to it rotating, but generally it's someone who finds that interesting and goes and talks with people and likes talking with people. What are you worried about? What keeps you up at night? What are you hearing about this technology? Are you getting, are you getting the sense that technologies are solid for our needs? What are we hearing about? Oh, by the way, project manager should be driving training going on in the team. Like make sure someone's training people in React Native or in Flutter or PWA development, progressive web app, or development for React or what have you. But a risk manager should be like inquiring where the risks are, what's soft, what's not proving out well, what are people really worried about, and gathering that information. And they should be familiar with what it takes to talk about things like contingency plans, mitigation mitigation efforts, etc., for the project. So they have to be really vested in it. Like they have to be, confident. But if you want to rotate it, I think that's a innovation I'm willing to support. Let's give it a try if you'd like to do that, and we'll learn from it. If there's one thing that's most important, ladies and gentlemen, it's learning from mistakes. Look, trying something and learning from it, there's no shame associated with learning from your mistakes. I mean, that's how you get forward. A mistake can bring you forward in life if you're honest and you learn from it quickly, and you can try to prevent it in the future, or if it happens, detect that mistake as quickly as possible. That is a lot of what this class is about. It's not about purely preventing mistakes. It's about learning from them quickly, preventing them in the future, or if you can't, discovering the problem as soon as possible and being honest and dealing with it quickly. I will reward it when mistakes happen, and there's that response. Okay, we're over time now. Folks, I want to thank you for bearing with this remote delivery. I care a lot about this class, and it pains me to not be there in person. It's I know this is not as good as being there in person, but I really look forward to seeing you on Tuesday, and I'll send some more needs. Thanks very much. Good talk. Keep the questions going. Keep the feedback going. Keep that contributions. Okay. Good stuff. Good luck with the start of semester there.